January 24, 2020, the Watson Grinding and Manufacturing Company in Houston, Texas. An accidental release of propylene accumulated inside a building and ignited, causing a massive explosion. The explosion fatally injured 2 workers and a member of the public. Hundreds of nearby structures were damaged, including homes and several businesses.
Our investigation found that Watson Grinding did not have an effective system in place to address potential hazards in its propylene process and did not have a mechanical integrity program or written operating procedures. This tragic incident was made even worse due to the lack of emergency response training for employees at the facility. As a result, 3 lives were lost and the surrounding community was put at great risk.
The Watson Grinding and Manufacturing Company was comprised of several production buildings, as well as a company gym. It was located in a densely populated area of Houston, Texas. The company specialized in machining and grinding services, as well as applying high-performance coatings, particularly high-velocity oxygen fuel, or HVOF coating. HVOF coating extends the service life of metal parts used in highly corrosive environments, such as specialized chemical, mining, and aerospace equipment. One of the buildings at the Watson Grinding facility was known as the Coating Building. Inside were 8 coating booths, 6 of which were used for HVOF coating. The process of HVOF coating involved propylene, an extremely flammable hydrocarbon gas. Propylene was routed into the coating building through piping connected to an outside storage tank, which was located in a separate area of the facility. On the day prior to the incident, operators shut down the individual coating booths and the coating supervisor closed and locked the coating building. But the CSB found that there was no established policy or procedure for isolating the storage tank at the end of a workday. Neither the manual shutoff nor the remote shutoff valves located at the propylene storage tank were closed before the workers left for the night. At some point overnight, a degraded and poorly crimped rubber hose, which connected to the propylene piping, disconnected from its fitting inside one of the coating booths. With the shutoff valves to the propylene storage tank open, flammable propylene was able to flow freely from the tank through the piping and into the coating booth. The coating building was equipped with an automatic gas detection system that included wall-mounted gas detectors inside each booth. The automatic gas detection system was meant to alert operators to a leak, as well as trigger remote shutoff valves to stop the flow of propylene. But the CSB found that several years prior, Watson Grinding disconnected the booth's gas detectors from their computer control system. This rendered the automated gas detection shutoff system useless. As a result, there was nothing in place to stop the flammable propylene from accumulating to dangerous levels inside the coating building. Around 3:30 a.m., 2 employees arrived on site to exercise at the gym prior to their workday. One employee could smell what he believed to be propylene outside of the building and insisted that the 2 of them investigate the odor. Just outside the coating building, the employees could smell a strong propylene odor and hear a loud hissing noise coming from inside the building. They suspected there was a leak inside. At around 4 a.m., they returned to the gym, where they texted the coating supervisor and called the plant manager to alert them of the suspected leak. Neither the coating supervisor nor the plant manager advised the 2 employees to evacuate the area. Instead, one of the employees decided to exit the gym to investigate the leak further. At 4:19 a.m., the coating supervisor texted all coating booth operators, alerting them to a potential leak and telling them not to start up yet. But shortly after 4:23 a.m., a coating booth operator in possession of a key to the coating building arrived at work to open it up. As he entered the building and turned on the lights, the accumulated gas ignited, causing a massive explosion. The coating booth operator and the worker who first noticed the leak were both fatally injured by the blast. A nearby resident died 2 weeks later due to injuries sustained at his house caused by the large explosion. The explosion affected over 450 neighboring structures, including homes and businesses, with some sustaining major damage. The explosion also caused significant damage to Watson Grinding, and the company, which employed 130 people, eventually filed for bankruptcy and ultimately closed. The Chemical Safety Board launched an investigation and found 2 safety issues contributed to the deadly incident. They are process safety management and emergency preparedness. The first safety issue is process safety management. The CSB determined that neither OSHA's Process Safety Management Standard nor the EPA's Risk Management Plan rule applied at Watson Grinding. Therefore, the company was not required to implement a process safety management system for the propylene coating process. But the CSB believes that several elements of an effective process safety management system, if implemented, could have helped prevent this incident. Those elements include process safety information, process hazard analysis, management of change, mechanical integrity, and operating procedures. For example, Watson Grinding did not maintain important process safety information for the automated gas detection system installed inside the coating booths. This led to this critical safety system not functioning on the day of the incident. The wall-mounted gas detectors inside the coating booths were originally configured to transmit a signal to a computer control system if a dangerous amount of flammable gas was detected. The computer control system was then to trigger alarms to notify employees of a release, automatically start up the booth's exhaust fan to help remove the flammable gas, automatically close a remote shutoff valve located inside the coating booth, and automatically close a remote shutoff valve at the propylene storage tank. But years prior to the incident, the gas detectors had been disconnected from the computer control system. Gas sensor calibration contractors visited the coating building in 2013, 2016, and 2019 and raised concerns in writing about the disconnected automated gas detection system. And the CSB learned that Watson Grinding management also had a discussion just 2 weeks prior to the incident about how the booth's gas detectors were disconnected and needed to be fixed. But no action was taken, and this critical safety system was not functional on the day of the leak.
We found that Watson Grinding did not maintain engineering drawings and additional documentation on the system, did not maintain the automated gas detection system in working order, and did not train its employees to use or maintain the system effectively. This critical information could have helped keep the automated gas detection system working, which could have prevented this incident.
The CSB also found that Watson Grinding did not perform a hazard analysis on its propylene process to identify the hazards of a propylene leak and consider the critical safeguards necessary to control those hazards.
A hazard analysis should have identified that the gas detection system could no longer respond automatically to an identified propylene release. Action items to restore this critical system's functionality should have been promptly developed and implemented.
Additionally, the CSB found that the hose that disconnected and led to the propylene leak was a rubber welding hose that replaced a more robust copper tubing connection. The less expensive rubber hose is not recommended for propylene service because the oils in the propylene fuel gas can cause the hose to form cracks and lose pliability. But the CSB could not identify documentation showing that Watson Grinding performed a management of change review to identify the potential hazards associated with changing from the copper tubing to the rubber hose. Further, the CSB found that Watson Grinding lacked a robust mechanical integrity program. Such a program would have ensured a system was in place to guarantee inspection, testing, and preventive maintenance of the automated gas detection system, which would have kept the system in working order. And finally, the CSB found that Watson Grinding lacked effective operating procedures, such as a written coating system shutdown procedure that called for closing at least one of the shutoff valves at the propylene storage tank at the end of each workday.
Companies have a duty to ensure the safety of workers at their facilities and protect surrounding communities and the environment, regardless of whether they're required by regulation to apply a process safety management system. This tragic incident could have been prevented if Watson Grinding had developed such a system for its coating process.
As a result, the CSB made a recommendation to the Compressed Gas Association to urge member companies that handle hazardous chemicals to share information with their customers about the safety issues described in the CSB's Watson Grinding report and why their customers should develop and implement effective process safety management systems. The second safety issue found by the CSB at Watson Grinding is emergency preparedness. The CSB found that Watson Grinding had a written emergency response plan in place at the time of the incident that identified propylene as a significant fire hazard. However, the plan did not address any additional hazards of propylene or discuss how to respond to a leak or suspected leak. Watson Grinding also did not formally train its workers to recognize or respond properly to a propylene gas release. Therefore, on the day of the incident, workers did not evacuate the area after suspecting a propylene leak, did not prevent others from entering the area, and did not contact emergency responders for help.
Facilities that handle flammable gases or other hazardous materials should ensure that there is a comprehensive written emergency response plan that adequately addresses all actions to be taken in the event of a chemical release. Workers must be trained on the plan, and periodic drills should be conducted to ensure the plan can be effectively implemented.
This deadly incident could have been prevented if Watson Grinding had implemented a process safety management system to address the hazards of its coating operation. And even if a leak still had taken place, an emergency response plan could have prevented the tragic loss of life that occurred. We urge companies to develop and implement effective process safety management systems and emergency response plans so that something like this never happens again. Thank you for watching this CSB safety video.
For more information, visit csb.gov.